Okay, so we'll proceed with the introduction to the process engineering. So it's all about understanding the basic engineering package, then deliverable of process documents, then information available in process flow diagram, PNID, and process data sheets. Then use of process flow diagram, PNID, and process data sheets. So these are the basic things. First, we will go with the basic things, then we will move further. Then understanding application of process equipment such as pumps, tanks, vessels, exchangers, columns, compressor, etc. In various process and connectivity of process and utility lines. So, also understanding the symbolic representation of process equipment in PFD and PNID. Then process flow diagram. Here you can see a typical process flow diagram. So if you want to draw from a scratch, then what are the things to be taken care? That also we will see in a process flow diagram. So as you can see here, two equipments are there. Then two pumps are there. One is reboiler, one is condenser. Yeah, one is condenser. So how to represent heat exchangers or any you can see here pump or equipments or specific control valves which from process point of view which are important, those we will specify in process flow diagram. As you can see here, one control valve is shown at the top for sweet gas and one is at bottom for rich amine. So this is the basic you can see typical operating ranges. So absorber 35 to 50 degrees Celsius and 5 to 205 atmosphere of absolute pressure. We'll see this. Then material and energy balance. Then line sizing and PNID diagram. So single phase as well as two phase. So guideline for preparation of PNID and sample PNID preparation. So have you prepared any PNID yourself?
Yes, sir. Manufacturing of ethanol the last 15 days back I have prepared, sir.
Okay, okay. So with which reference document you have followed for preparing PNID?
PNID तो कोई स्टैंडर्ड बुक था ना सर, केमिकल टेक्नोलॉजी.
Okay. No, but your existing plant PNID must be there with you, right?
Yes, sir.
Yeah, but as working as in production, you don't have to prepare any PNID, but you have to study the PNID
खुद
and see the
मेरा प्लांट का पीएफडी तो बना है सर.
Acha, acha. Okay. So you have prepared PFD. That's
Yes,
good.
sir.
Okay, okay. So we will see in detail what are the things we have to keep in mind while preparing a PFD. Then from PFD, how we have to prepare a PNID. So PNID is not but just developing a individual equipments with its accessories and incoming outgoing lines like pump will have a suction discharge and it will have some suction assembly discharge assembly like that every equipment will have its own accessories, one suction line, one discharge line, and fittings, instrumentation. So all these things you have to develop in a PNID. Then your line size will come, pipe class will come, then whether it's a insulated or non-insulated, then line number will come. So many things, so many details you will add to the PNID. So we will see how
Sir, what about BFD, sir? Block flow diagram.
block flow diagram is a basic things you can develop. It's not a you just have to be clear about what are the raw materials are used and what are the reaction is to be
Carry out
reaction is there in
process.
your process. and what are the unit operations you are going to perform, like in your existing product, what are the unit operations you are performing. Say for any one example you can give me, which are the unit, like a distillation or absorption, or say
Separation.
maybe separation. Yeah, right. So this unit operation you have to know. The raw material product you have to know. So you can build a block flow diagram from it. So that is very simple. You have to just include all the unit operation. That's it. So moving from block flow diagram, you have to develop process flow diagram, process description, then subsequently PNID, PDS. Okay, so we'll see how step by step we'll move ahead. So now jumping to the pump calculation. In pump calculation, you have to face is the pump sizing calculation, NPSH concept, preparation of pump data sheet. So here you can see one vessel and there is a pump placed here. This is the pump, and if you draw the drawing, it will look like this. Here is the pump, here is the suction pressure gauge, here is the discharge pressure gauge, and here is the height of the liquid, you can see. So you have to calculate basically the net positive suction head available for this pump, and then you have to calculate the suction pressure first. Then from suction pressure you will get the net positive suction head. Then you have to calculate the discharge pressure, then ultimately the differential pressure and the shut off head, pump power required, brake horsepower required. So all these terms you will do in pump hydraulic calculation, and same all the results you will put it in the pump data sheets. So are you getting it? So pump calculations, then we will move further for heat exchangers. So we will do the thermal sizing of the heat exchangers, and heat exchangers can be of many types, like heater, cooler, condenser, subcooler, reboiler, evaporator. Based on their use, we term them as a cooler, condenser, subcooler, reboiler, evaporator. Means in your existing plant, you might have heat exchangers which are acting as a cooler or maybe acting as a reboiler. Okay, so thermal sizing of heat exchanger we'll see, and the preparation of process data sheet of heat exchangers. Okay, so have you prepared data sheet
Okay.
heat exchanger?
No, sir.
Okay, so we'll see it. Okay, then
Okay.
distillation column. So we'll see some introduction to distillation column and uh, basic know-how about the packings use and the and scrubbing operation. What are the distillation column can be used as an absorber or scrubber or separator, or you we use for a multiple application heat exchanger. Moving further, absorption column, we so sizing of absorption column, we'll see how absorption columns are sized.
Okay, sir.
Then we have a safety valve. Do you have any absorption column at your place? Any scrubbing action? You are trying to
Yes,
separate
sir.
some sulfur dioxide coming, and you are means trying to separate it SO2
Yes,
with the
sir.
help of
Nice.
H2O. Okay, so we'll see some absorption column, how the separation is achieved with the help of a cross flow, counter current flow of the air and water, that we will see. So moving further, safety valve, then safety valve, rupture disc, safety valve and rupture disc sizing we will see. Here you can see a particular safety valve. This is a conventional safety valve. It have some spring arrangement which will help to protect your equipment from overpressure. So you're under some condition, if your equipment gets pressurized, this valve will open. The spring has certain tension inside it, so it will keep your equipment protected. So we have to design this safety wall such as set pressure of the safety wall and all those things. Okay, so we'll see the safety wall. What are the types of safety wall? What are the criteria of selection of safety wall? Then how to size a safety wall with the help of API 520 and 521. So moving further, we have agitators, reactors, phase separator, cyclones, and venting calculation. Then sizing and preparation of data sheets of tanks, vessels, vertical, horizontal, phase separators, tank venting requirement. As you can see here, this drawing you can see here. This is a separator. Here we can have liquid gas separation, and this is a horizontal
Yes.
separator. Moving further, HAZOP study or SIL analysis. HAZOP is nothing but your hazard and operability study, which is to be carried out for safety of your plant and for the sound performance of your plant. So HAZOP is to be carried out. What are the things we do while carrying the HAZOP? What are the guide words we use? What is the procedure for HAZOP? Who are the people who take part in the HAZOP, that we will see, and practical example of conducting HAZOP study. So this is our course. In short, I have made it in the PowerPoint presentation for this. So in short, we are going to cover this. So let me close this and let's move to some other things. Like, so general will see some design of venturi, then some fundamentals, basic designs, and design of vessel for external pressure, distillation column design, emergency vent, then engineering design guidelines. Which are the engineering design guidelines? Flash calculations, kettle reboiler, knockout drum sizing, RO sizing of gas, then RO sizing natural gas, general RO sizing, scrubber calculations, separator sizing. Then what are the engineering thumb rules? Then vessel volume, if you have to calculate vessel volume, how to calculate vessel volume. And then some design standards of the reputed EPC companies we will see. So how to calculate the instrument and utility air system capacity, that also we will see. Okay. So these are the general things, and then in heat exchangers we will see some actual calculation how to calculate heat exchanger. So this is the procedure for calculating heat exchanger design. We'll see step by step. Then line sizing. Line sizing guideline, we have certain guidelines for line sizing. So if you have this KLM version, you can go through it, and based on the guidelines provided here, we will try to line sizing. We have certain calculation sheets. We'll see how to, with the help of calculation sheet, you can size. Here we have taken fluid as a air. So line sizing for liquids as well as line sizing for single phase as well as for two phase, we will see. So this is a basic line sizing calculation sheet. You might be having your own, you can develop your own, but you have to see what are the things to be ensured before you form your own calculation sheet. Here we you can see there are number of lines, 1, 2, 3, 4, 5, 6. So each line will have its data like flow rate, density, viscosity, and based on this data, you have to calculate the pressure drop across the line, and accordingly, you have to design the line size and overall pressure drop across that line, whether it is at pump discharge or suction. See here the description you can see of the line from to, you can say, cooling water supply, cooling water return. Then you have a line number certain assigned to it. Then you have this input data. This data you can see. this selected this data, you will get it from the high seas or from your project data or high seas. You can get this data. Once you get this data, you have some velocity criteria. As you can see, I have inputted here some velocities. Based on the description of the line, you have to choose these velocities, whether 1.5, 2.5, 1, and these are the assumed velocities. Then we will have the actual velocities. We will find the inner diameter of pipe. Then we will select a nominal size of the pipe. Then eventually what we do is find the actual velocity based on the formula Q is equal to area into velocity. That is continuity equation, right? Yeah, and then finally you can get the pressure drops, total pressure drop in pipes and fittings you will have here, and we have certain limit or permitted pressure drop, which is say zero point 0.5 is the allowable pressure drop in your line. You have to verify that, yeah, here I am getting 0.27. So my calculation seems okay and my pressure drop is within the permissible range, and I will stick to the line size. Means I'll go ahead with this line size. Say here we have choose schedule 40 pipe and 6 inch. I think, yeah. Here you can see 6 inch.
6 inch pipe.
You have, yeah,
This,
here you have
this
standard.
Darcy equation.
Yeah, Darcy-Weisbach equation we will be using here.
Yes.
Okay, so you can see here drop down will appear where you will have already feed a standard line sizes here. Okay, so once you calculated this at nominal bore, if you arrived at nominal bore, then you can select the, as per this calculation you can select this line size. See here 3.88, so I have selected 4. Likewise everywhere. So this is a simple, so line sizing we will see, and guidelines, what are the guidelines and what are the criteria for line size for single phase and for two phase. Then moving further, say relief wall, here we'll get overview of API 520, 521. Then introduction to pressure relief wall, selection sizing criteria. Then what are the scenarios for the safety wall? What are the scenarios to be considered for calculation of pressure safety wall? That we will see. So this is our course. In short, I think we have discussed each part. So you have any doubts or you have anything to say additional that look, I want this also. Yes. Let me understand what are our course offerings. So let me know. Are you comfortable with these topics, or if you have in your mind certain topics are still to be there or something? So let me know, because these are the standard topics which I have choose from the industry and from my experience. But still, depend on your experience or in kind of industry you are working, you might be having some. You can let me know any topics, and I will check whether I can give you anything on that or okay. So we'll stop
Yes,
here.
like